about software development, architecture, and specifically cloud and serverless technologies, something I'm very interested in these days. So tonight we're going to talk about some microservices and serverless architecture. So what are microservices? Anyone here familiar with microservices or using microservices? Show of hands. Awesome. So microservices is an architectural style. I really like what Martin Fowler said about microservices. It's basically an approach to developing a single application. So sometimes there's confusion out there about what this architectural style is. It's meant to decompose a monolithic type application, something big, something that's hard to maintain, manage, develop, maybe have multiple teams working on. It's very complex. This type of style in development is to decompose that into a suite of small services, as Martin Fowler says. So these services are generally organized around business capability, and they are small, lightweight, and independently deployable. If you're not familiar with Martin Fowler, I suggest you go out and read about him. You should know about him if you're in this industry. So microservices are loosely coupled, like I said, independently deployable. So I can deploy service A without having to worry about services B, C, D, and so on, right? They're organized around business capability. We'll talk about that in a minute. Usually owned by a small team. And this is, so when I'm talking about these complex applications, usually microservices usually don't really apply to just a small application and a small team. You're talking about something that's really big and hard to deploy, hard to manage, and this style is meant to ease the maintenance and deployment of that. So on the left, that's your typical monolith. That's what I would think most of us are familiar with. You have your user interface, your business layer, data access layer, and a database. Where in the microservice world, right, generally you have an API gateway that sits in front of your user interfaces and then all your microservices behind them. That's the recommended approach. You get into problems when you have the front end components talking directly to the microservices. Maturity is demanded when you're dealing with microservices because there's a lot of overhead required for microservices. Kim Clark from IBM, she says microservices require mature delivery capability. So you need continuous integration, deployment, and fully automated tests are a must. Developers who write significant changes to provide the right separation for concerns in a microservice environment. So if you're a small shop and a small team and you don't have some of these capabilities like continuous integration, continuous deployment, fully automated tests, microservices may not make sense for you. So microservice or API, what's the difference? Does anyone want to take a stab at that? All right. They're very similar. An API is not a microservice. APIs expose data and behavior to its consumers behind some interface. APIs are a contract between one system and another system or other consumers, right? Microservices is an architectural style. It's a way of developing and decomposing your application. Microservices may make up an API, but there's not a one-to-one relationship. And I'll show a picture of that in a minute. More than one microservice may make up a single API endpoint. So you may have an endpoint that calculates somebody's benefits over the next year or something like that and sends it back. Well, in the back end, it may make 10, 20 different microservice calls to figure out information based on whatever the input is, right? So they're not one-to-one. So when we look at this, right, we have your APIs on the outer layer of your application. Your API is the interface. It's what you're exposing to the outside world, everything outside of your application. The microservices in the inside side, those are the components. Those are the things that make your application. You can have a single microservice that may be exposing some functionality as an API. You may have microservices that don't even expose, they're not exposed to the outside of the application, right? And those APIs usually should be sitting as a gateway. Your gateway is what says, okay, here's what the outside world can talk to. So Martin Fowler is very opinionated, especially when it comes to microservices, and for good reason. He has a lot of experience in our industry about a lot of things, right? But his primary guideline is, unless your system is not very complex and it's not hard to manage as a monolith, don't do microservices. Because there's so much overhead that's required. And I'll just in our example application later tonight, you'll see the kind of overhead that comes along with it. So he says the complexity that drives us to microservices comes from many different sources. And that includes dealing with large teams. So if you have like a team of like 20, 50 developers, maybe, that is a reason to break the application apart into microservices and smaller teams. Supporting many user interaction models, or allowing different business functions to evolve independently, and scaling. But the biggest factor is that of sheer size. People finding that they have a monolith that's too big to modify and deploy. So I don't know what type of systems you're working on today in your work environments, but in a lot of cases, I would say from my 23 years of experience, most things don't need to be microservice architecture. But if you are going to build one, hopefully I can give some insight in how to effectively build microservices. And tonight we're going to be looking at cloud technologies. So does anyone want to take a stab at what serverless is? All right. So traditionally, we as developers and our DevOps teams or operation teams, we develop applications or systems and we deploy them to one or more servers. We probably have multiple environments that we deploy our applications and systems to. Our servers are managed by some development teams. Sometimes, if you're a small team, you manage your server hardware. Or you have a DevOps team or an infrastructure team that manages that hardware for you. So those development or DevOps teams are responsible for ensuring your uptime, making sure you've got security patches and OS updates, licensing taken care of, lots of things just to keep that hardware and that infrastructure up. So teams got to be worried about scaling. So if all of a sudden you get a lot of traffic to your site or your application, you got to be able to handle that, right? And usually that's a manual process when you're not in the cloud and trying to prepare for increase of traffic or load or decrease in traffic load. And all of this that we're talking about, equipment, licensing, maintenance, the people involved, that's money. That costs money. So serverless is a cloud provider concept. Now there are some serverless frameworks or implementations that you can run on premise, like Apache OpenWhisk. But generally it's a cloud concept. So your cloud providers will execute code by dynamically allocating resources for that code, and then they'll take it away when it's not being used anymore. That's kind of it in a nutshell. As a developer or consumer of serverless technologies, you're only charged for what you use. So thinking back to the traditional way, where you're maintaining lots of hardware and infrastructure, software licensing, patching, all of that, right? This way of development should save a lot of money. The code executed is stateless. So once it's up, you can manipulate state in memory, but once it's gone, it's gone. There's no state around for the next time it comes back. So you have to put data in some permanent data storage, like a database, blob storage, something like that. In serverless world, your code is triggered by events. It's very event-driven. So that could be an HTTP request, or it could be a file upload. It could be a queue dropped message dropped in a queue. It could be an event on a database, depending on what cloud provider you're working with. So what this does is it abstracts you and me from maintaining infrastructure and everything that comes along with it. We can just focus on code. In the serverless world, scaling is automatic. It will automatically detect load and increase and decrease scale for you. So tonight, I have a sample application. Before we jump into the sample, is there any questions so far about serverless and microservice?
Serverless is not tied to microservice. Is that right?
They fit well together, but no, it's not tied to microservice. Because of the nature of serverless technologies, they fit very well with the microservice architectural style. Good question. And we're streaming, so.
Okay. I was just going to say, so I know serverless can save money for some types of jobs. Are there use cases where you would typically split the application, or is that?
Yeah, so good question. So if you have something that's going to be a long-running process, very resource intensive, serverless may not make a whole lot of sense for that, right? Serverless is for, it fits well in the microservice world because generally your services are going to be stateless. It fits well for short-lived processing, right? And chaining things together. You'll see some of that tonight when you're chaining things and developing an event-driven approach. But when you're going away from that in a more traditional, or if you have long-running, heavy processing type work, serverless may not be the best option for you. Any other questions? Awesome. All right, so this is my sample application, Fix a Leak. So the problem, the hypothetical problem, we have potential customers that either have leaks or clogs and require a plumber quickly. So, plumbing issues can occur at any time of the day or night, and they're usually inconvenient. And plumbing rates can vary from company to company and the times of the day or the year, if it's a holiday or not. And how do you know if your plumber is reputable? So you guys can go home tonight and start this business. I'll just take 10% of the profit. So the solution is Fix a Leak, where we provide a service where all plumbers have been previously vetted. Plumbers agree to work under Fix a Leak fixed rates. Customers use the Fix a Leak app to submit a job any time of the day. Our available plumbers that are nearby will be notified, and then they can accept the job if they want. And Fix a Leak will monitor the job and communicate with the customer. So let's look at the workflow. So simple workflow. Basically, customers submits a job through the app or website. We notify available plumbers in the region, in the area, and then wait for an acknowledgement. If we get a successful acknowledgement, we assign the plumber to the job, notify the other plumbers that, hey, this job's not available anymore. We also notify the customer, hey, your plumber is en route. And then we kick off the job, and we monitor that job and wait for completion. When it completes, then we'll recycle the plumber back into the available pool of plumbers and complete the job, blah, blah, blah. Okay. Any questions about that? All right. So the basic architecture looks like this. We're going to have our front end, and I apologize. I wasn't able to create the front end application in the time that it was given to me. You can thank Ben Coates for that. But then we have API gateway, which behind the gateway we have our jobs microservice, plumbers microservice. I could have put in a customers microservice, but for the time, these two microservices will suffice. Then we have an orchestration microservice. So one of the cool concepts is something called a durable function. All the cloud providers have this concept. A durable function is one that is sort of long-lived, right? It comes alive when events trigger it, but it'll go back to sleep, and it has a little bit of state in knowing where it is in the process. So if you're trying to orchestrate a lot of different pieces and parts, kind of like we saw in the workflow, you can have a durable function. And in this case, our orchestration microservice handles that. It's going to control the workflow that we looked at. And we're using Azure EventGrid to publish events, and then we have a logic app. So if you're not familiar with Azure, they have a concept called a logic app where you can integrate a lot of different things, and I'll show that to you tonight. In this case, this thing will respond to the events being published and handle our notifications. All right, so let's get to the code. Any questions so far? All right. All right. I want to open up Postman. This is how we're going to execute a lot of the API calls tonight. All right. While that's loading, so you can see over here in the solution, we have the first three, the function apps, are the microservices. We got the jobs microservice, we got the orchestrators microservice, and the plumbers. Then we have some shared pieces where we have some common services, and we have some shared models. So we got the plumber, the job, the customer. And then, so what I would like to do is first start with the jobs microservice, because this is where everything is going to initiate out of. You can see this is the actual function, the serverless function that we're developing. Visual Studio, both for the Mac and Windows, has a very tight integration with Azure Functions. It makes it really easy for local development, and I'll show that in just a minute. So we have a few functions in this class. We have the get jobs. We have and these are endpoints. When this function starts up, there'll be RESTful endpoints. You can see that you can put authentication on your functions, but when you sit your functions behind or microservices behind a gateway, an API gateway, it's generally you allow the gateway to handle all the authentication and authorization, and you can manage that in one place. You may want to have authentication just between the gateway and your microservice, just like API keys, to validate or authenticate that the API is calling you. But aside from that, your API gateways are usually the best place to manage all that. All right, so this responds to the get verb and under the routes job, and you can see what I'm doing here is I'm just calling my persistent service. So for this app, the persistence is Cosmos DB. It's a NoSQL database in the Azure cloud. It's very scalable to multi-regions and very fast. And so this is where we're persisting the jobs and all the information. So let's look at the create job. This is the one where everything gets kicked off, right? So in the web app or the mobile app that I didn't develop, it would make a call to the gateway, which would ultimately call this create job. And this create job, you can see right here, we get the stream from the request, and then we serialize that into one of our models, this job item. And if we look at that, the job has all the basic information on there. We have a code, we have customer information. The plumber and available plumbers are null by default, and I'll show you how those things get populated. We have a destination, that's just a longitude coordinates. And then some other properties, when it was accepted, when it ended, how long it took. All right. So what happens is once we do some basic validation of the request, then we go ahead and call the persistence service to basically save this thing. And this, let's go to that. This right here handles, generating a job code and the information that's needed for the unique ID to be stored in our NoSQL database. And then we store it in the document database in Cosmos. And then lastly, what we do is we spin off an event. So you can see right here, change notifier service, we're saying, hey, a job created. So let's look at that. Oops, that's on my interface. Let's go to the implementation. So this right here, what we're wanting to do is trigger the job manager. So our orchestrator. Remember, if we were looking back at that picture, the orchestration microservice, we're wanting to say, okay, this job's been persisted, and we want that orchestrator to come alive and start the whole workflow process. So I had a couple different options. I can either call it direct, the way I'm doing right now, just doing a HTTP post, or I could have dropped a message on a queue, let that thing pick up. I could have allowed the job monitor to pull my Cosmos database and look and be triggered by an event there. For simplicity, I'm just making an HTTP post. There's a potential flaw here is if for some reason that URL wasn't available. A queue might have been a better option to drop it in there. But for tonight, this works. So what it does is it'll call the job manager and say, hey, here's the job code. Go do your thing. So that's our entry into the system, or to kick off that whole long workflow. Stop me at any point if you have questions or confused, or you see any code that looks interesting to you. All right, so let's look at the orchestrator, because there's two types of orchestrators. We have the one that starts the first flow, basically finding a plumber that's available and assigning it. The next orchestrator is the monitoring of the process. Okay, we've got a job, there's a plumber en route, I want to monitor that and figure out when he's done, okay? So the one that finds the plumbers and does the assigning of plumbers is the job manager orchestrator. But before I show you the orchestrator, let's look at the thing that triggers the orchestrator. Remember, I said the orchestrator is a durable function. This is just a normal function right here that starts the job manager. So if we go back and look at this, he's calling, so this is, the base URL comes out of the configuration, but it's calling job managers with a code. That's what this is right here. He's calling this route. And as you can see, this is a microservice calling another microservice. And what he does is he deserializes the stream, gets the job item out of there, and then he's going to kick off the durable function. Because a durable function can't, by itself, expose HTTP triggers or things like that. So you have to have something to kick it off. In this case, I have a normal Azure function that's taking the HTTP request, taking that request object and using it to start the durable function. So let's look at our durable function. It's called manage job. All right, and I prefixed it with O just to indicate that this is an orchestrator function. And you can see it has this attribute orchestration trigger, which this reminds me. Let's go back and look at the trigger. You can see what the triggers this function right here. So the start, the job manager, it has an HTTP trigger attribute, and it's defining that this gets triggered by an anonymous post to this route. I didn't really explain that earlier. So that's what triggers this function. And you can see that it also takes in a durable orchestration client. But what's really cool, you don't see this class extending any base classes or anything like that, right? It's just these attributes are what are used to define your functions. So going back to our orchestrator, this thing right here has some logging. And then what he does is he calls, so inside of this class, we have a bunch of different methods. So we have this particular method we're looking at is the entry point into the orchestration for this finding the plumbers, managing the job, right? But we have other steps in our workflow. Those steps that I showed in that diagram, that flow diagram, are defined by these different methods in here, right? So the very first thing that this orchestration does is, so that context, that durable orchestration client, the thing that's kind of managing the little teeny bit of state, is saying, hey, first step, call this method right here. This is a function. It's saying, hey, call the find and notify plumbers. All right. And you see, it's an asynchronous method. So it looks like this code would sit here and wait for it, but really what Azure does under the covers is it makes that call, and then it just kind of goes to sleep, and it just kind of has a polling mechanism. It's basically using, if you're familiar with web jobs, that technology behind the scenes just to come alive periodically and see, have I gotten response back from this activity? And so this is kind of a way you can sort of do a long-running task and not spin up and use a lot of Azure resources and spend a lot of money. So makes the call, and then it just kind of sits in hibernation mode and waiting for a response. But it's really quick. To get, okay, go call these plumbers, let them know that there's a job available in the area. Next thing it does is it starts a loop on a timer. Well, kind of not really a loop, but we provide a cancellation token, and we start a timer. And I think right now the default that I have set is, yeah, see, it's reading my settings service to get the timeout period. I have it for 2 minutes. Maybe in real production you'd want it a little bit longer than that. But so then we create a timer on the durable function. So this is all on the context. We're saying, okay, we're going to let this function will be alive sort of in a suspended state for 2 minutes. And then what we're waiting for is an event on the event grid. You saw that event grid? We're waiting for a plumber acceptance event to say, hey, I accept it. So he's going to sit there kind of in this suspended state, coming alive periodically until we get an acceptance from a plumber. If it doesn't get one, it'll just time out, and then that job is basically done. And we'll update the plumber on the job object. We'll update the accept code to timed out. So when we go look in the database, we can see, oh, we got timed out jobs. All right. If we get an acceptance, all right, what we're going to do is then call another activity in this workflow called assign job plumber. So if I look at the job item, and this all makes sense once I start running it, all right, we're going to assign whatever plumber accepts to this property. So that way, if we have a reporting interface or some admin interface, or even for the customer, right? They want to know who's coming to see them. We have who's the plumber that accepted and they've been assigned. So we update the database, basically, right? We update the plumber. The next thing we do is we say, hey, other plumbers, too late. Joe Blow got to that first. All right? Then what we do is we spin off another durable function, which is an orchestrator called job monitor. And we'll look at that one in just a minute. So unless something fails, right, that's kind of the workflow, right? That's that first side of the workflow if we come back over. Right? It's that first left side. That is the workflow. The job monitoring is very simple. We could have made it more complex, but for this is good enough. So if we down here is the other steps, right? Here's the find and notify the plumbers. That one basically says, hey, give me all the plumbers based on this destination and latitude. And no, I didn't implement all that logic to figure out who's local and who's not. And then what this does, this line of code, updates that job item. There's a collection of available plumbers so that the orchestration knows who to contact. Right? And so I could have, this property right here says whether I call the database directly. I'm kind of cheating. I'm calling the Plumbers Cosmos database directly. I should technically, as I'm adhering to good REST contracts, I should be calling that Microservice API directly. But for time's sake, I called the Cosmos database directly. So don't do that. And then this right here, this last step right here, externalize. And this is what's publishing an event on the EventGrid. And I'll just show you what that looks like real quick. Basically, I have this utility function that says, hey, here's the job, and here's the subject. Put it on the EventGrid. We go look at that. Basically, it's really simple. We just build a dynamic object, put my API key in the headers, and then I just do a simple post to the EventGrid URL, and EventGrid handles the rest. All right. So, any questions so far? I'll show it all working in a minute, and we'll kind of look at some of the flow. All right. So let's quickly look at the job monitor orchestrator. So this one I've implemented with a queue trigger. So the job manager, the one that's responsible for assigning plumbers or finding plumbers, was an HTTP trigger. This one is a queue trigger. So that very last step down here is dropping a message on the queue, which the orchestrator picks up. So this queue is called job monitors queue. And this is just an Azure storage queue. Super cheap, super simple, nothing fancy. Right? There's more advanced queuing technologies out there, but for this sake, this works great. And I'm specifying the storage queue connection string right here. What I do is, and all that's on that queue is the job code. So it knows, okay, this is the job code. I can call the job API, get the information about that job, and start the whole monitoring process. So that's the trigger. Here's the orchestrator. So here again, this one's called O monitor job. And this one has an orchestration trigger. And again, we're getting this is a durable function. So it can stay around for a while. And it gets the code, the job code passed in. And then what it does is it calls an activity on this orchestrator called retrieve job code. Let me just show you what that looks like. So here's that function, that Azure function, retrieve job code. And all it does, so technically I should be going through the jobs API, but for quickness, I'm just going directly to Cosmos. But, so its steps are get the job. If they don't get the job, it throws an exception. Then I go, and if the job doesn't have a plumber assigned to it, because in that workflow, the plumber should have already been assigned before we start monitoring the job process, right? So we get the job, and we make sure we got a plumber, and then we say, hey, go get the settings from the settings service, because I want to see how long I'm going to monitor this job, and I have that all configured, right? So then this thing is going to create a timer, just like we did over in the other durable function, where we're waiting for some sort of response. Basically, it's going to call a function called job completion. I made this one super simple. If the plumber's lat longitude matches the customer's lat longitude, it's complete. There'll probably be a lot more steps in real life. So if you're going to go home and implement this business, you're going to have to flesh that out a little bit. All right, so then we also have a little safety net here. We don't want this monitoring process last forever, so based on the configuration, the max iterations, if it reaches that, then it's going to just time the operation out. Then what we do is, after that, we recycle the plumber. So we have an activity called recycle the plumber. So let me show you the plumber object. He has a property on him called is accepting jobs. So once he's assigned, I update this property to false. He can't accept any jobs right now. And then when he gets recycled, we set that back to true. And then the last thing is we complete the job. And all this does is set the end date on the job to whatever the date is, right? Any questions? Gary.
So you're using a durable function to kind of maintain the workflow, but one of the events in the workflow is it waits for an event to fire from somebody calling the API. Is there a reason to use a durable function as opposed to kind of getting the data from the database each time an event fires from one of those, other than obviously to do our
Well, in a true microservice environment, you see I'm making direct database calls, which I shouldn't be doing. I should be calling that microservices API because that data belongs to that. That's one of the precepts of microservices. It owns its own data. Data is not shared by other microservices. So that's one of the reasons it can be completely autonomous and independently deployable. If there's shared data, then you end up having coordination between multiple components or services, which you don't want in a microservice environment. I kind of broke the rules here to be quick, but generally, especially when you're dealing in the serverless world, you're event-driven. And so you need different events, whether it's a HTTP trigger. You saw I use a queue trigger. There's other things that can trigger that. I can drop it in a blob storage that'll raise in, and then those triggers, you want to have the basic information that your function needs. So in this example, I'm passing the job around all over the job item. And that's kind of my JSON objects you'll see that gets passed around through all the microservices because they share that data. But they're not, I am going directly to database in some cases, but generally you want to call the APIs so that they're loosely coupled. We don't want tightly coupled surfaces. Any other questions? Just some other things. I am using a NuGet library that's a Microsoft extension to the function, Azure Functions, that allows me to do dependency injection. Not sure if anyone noticed that. So like I have this settings service and this persistence service that handles providing my settings and data, where I could have just newed it up directly, but I'm using dependency injection. And the way we do that is, this is the library that we're including up here at the top, the Azure Functions Extensions Dependency Injection. In the first versions of Azure Functions, you couldn't do dependency injection. So this is really cool, makes your functions more testable. And then in here, in my startup class, I'm in the configure method that I overrode. That's where I have access to the DI container, and I'm adding my services there. And then when Azure function spins up, that quick come to life function, it automatically inject whatever dependencies I've defined in the constructor. So right here. So I have a constructor that takes those things, and I go ahead and assign that. So that's really cool. It makes it easy to test your unit test your functions. One other thing to note, you'll probably see I have this local settings.json. This is what you would do when you're doing local development, so you can point to your, have all your settings. And by the way, this is .NET Core 3.1 that I'm developing in. In my local development, I can specify the ports. And since I'm doing local development, I don't care about cores, which you would once your API gateway to kind of handle that with your clients. Not recommended just to let everything in production. But your local, you can see my local settings has a little X beside it because you don't want to include that in your repositories. All right, so I got all my connection strings, API keys, all that stuff in here. So that's how these different services get their information so that they can actually work. All right, so let's fire up solution. All right, so let me close these other ones that I completed. All right. So this is my Plumbers API. As you can see, it's listening on port 7071, API Plumbers. And it gives a little bit of information when it first starts up, telling about which version of the runtime, stuff like that. But you can see right here too that it detects what number of functions are in your assembly based on those attributes that we decorated our methods with. So you can see I've only got 2 API endpoints here, create plumbers and get plumbers, and then it tells you what those routes are actually, the mapping. So that's the plumbers one. This one right here is the big daddy one that has the orchestrators. We have 2 orchestrator microservices, job manager and job monitor. And you can see these are the functions it detected and what the routes endpoints that they're listening on. And this one's on port 7073. And then we've got the jobs. This is the one that handles all the job API calls. All right, one other piece of important information is this. I'm using Grok. Is anybody familiar with Grok? Yeah? It's a cool little local proxy tool, especially if you're working behind a firewall or something like that. And when you're doing local development and you want to expose services to something in the cloud. In this case, I'm exposing to EventGrid. EventGrid is going to be, I have subscribers to that, and I'll show that to you in a minute. But I need those things to be alive. So, well, while we're talking about that, let's just go over to Azure and look at it real quick. Sorry, I'm using my mobile hotspot, so it's not going to be the fastest. All right, so this is my resource group. I've just called it default, but you can see, let's see if we can. I've got several resources here. I've got the Fix a Leak event grid. I've got Fix a Leak notifications. That's the logic app that's going to handle notifying the plumbers, and I'll show that in a minute. And I've got a couple API connections that are used with this logic app. You can see Gmail and Plivo. Then I have my storage account. That's where my queues are. And then I have my event. And then I have my Cosmos database. Let's look at the event grid. So here's the EventGrid. I have 2 subscribers. I have a Logic app. That's the one I showed you a minute ago, and we'll look at that in a minute. And then I have the externalized job. This is the thing that's making a call to my in Grok. You can see I have a webhook down here. And so in Grok is running over here, exposing my local service. Then let's go over here and start playing around a little bit. So I have this. Let's close this over. I have this request. It's a HTTP post. Remember at the very beginning tonight I showed you an endpoint called create jobs. This is that microservice right here. We're going to give it some customer information and the destination, some lat long. If I had time to fully implement this out, this customer information would have come from a customer microservice after I forced the customer to create an account and log in. But for this case, this is how we're kind of mimicking the front end pieces, whether that's the mobile or so what we're going to do is we're going to post this thing, and then we're going to jump over and look at the microservices responding. All right, so I got a 200. That's good. And then it gave me back a job code. And let's shut up. All right. You can see I've got my customer information in there. It's got some Cosmos DB baked in stuff already. These properties right here, ID, self, correlation ID, all that, that's part of Cosmos NoSQL database. It puts those on there for you. Then I've got, you can see I don't have a plumber assigned, and I don't have any available plumbers assigned, right? It just immediately, this is the job service, right? The orchestration microservice is responsible for that stuff. And it's got, it hasn't been accepted, but it's been started. We don't have an end date or duration, right? So all that stuff's going to happen later down the road. Let's go back over here. Let's look at my, this is my jobs. Yeah, this is my orchestration service. Let's look at this thing. All right, so you can see right here, it received a post starting right here to that endpoint. And then you can see it starts executing the job manager. Then you can see the job manager orchestrator starting. And then executed. That's when it finished, right? Then we see the job manager coming back to life, and it calls that first activity, find and notify plumbers. All right. So it's sending out notifications to the plumbers, and then that ends right here. And it's just kind of in this polling state, waiting for a plumber to notify. So hopefully I am within 2 minutes, if I didn't take too long. I can come over here and acknowledge the job. So I already got a plumber code put in here already, because I just know what they are. We get a OK, 200 OK. What should happen? Oops. Yeah. And which one is it? Yep. All right. So let's see, where does it start? Where does it start? Okay, here's the message right here, the HTTP post. Job managers acknowledging. We can see that Azure functions coming to life. Then down here, Where is it? He's cleaning up. I must have not did it in time. Let's look though. If I take that, hang on, where's the get job? If I go look at that job. All right, so this job, oh, let's look. It doesn't, so I didn't respond in time. That was obviously outside of the 120 seconds. So it still has the available plumbers listed on there. All right, so let's do this again. We'll do it a little quicker. We'll create a job. We'll go ahead and acknowledge the job. Then if we come back over here, all right, we see things happening. All right, so we actually see right here, ooh, it's going too fast, going too fast. Up here, we got through the whole, see here we are notifying the customer. We should have been notifying the other plumbers. Yeah, here's notifying the other plumbers. Job's done, been taken. Notifying the customer. Then you see the job monitor actually kicking off. The other orchestration microservice, it's kicking off. It is coming to life. And you can see that was created via a trigger, or a queue trigger. Because, and I didn't really show you that, but if we go back to my account, look at queues. Here's the job monitor queue. It's empty right now because the Orchestrator picked it up, but that's where we just post the job code in there, and it picked it up, and that's when it came to life right here. And then, let's see. And there's the job code that it pulled out of the trigger. That's the job code that got created. Then it calls that activity, retrieve the job. And then we should see starting job, retrieving the settings. And obviously these are all things that you'd want to update the front-end mobile app, you know, maybe some notifications so they know. And then we start that little loop process. Check job completion, and basically they're looking to see if the lat longitude match. In this case, I already set them to match, so it instantly completed it. And you can see we're starting to recycle the plumber, putting him back, see, and then we should complete the job. That's the last piece. So if we go look at my email, I'm going to show you my Gmail, people. We should have some messages in here, as long as I'm in the right account. Oh, there we go. So I put the same email address for every single plumber, so I got a ton of emails for these different. You see, I got emailed for the first job, then I got emailed for the second job. So we got, basically I probably put some sort of link in here for them to accept it or something like that, but I didn't really have time. But you can see, and I'd probably translate that lat longitude to something specific or show a map or something like that, right? But you can see that's the notification. I should have got text though. I was experimenting with Plivo, but no, I didn't. So that was going to be like the icing on the cake. But you can see that's the notifications, right? So I want to, while we're looking at notifications, I want to show you that logic app. The logic app is what responds to those things. So if we come back, where's the logic app? Right here, fix a leak notifications. This is a super powerful piece of Azure. Technically, I could have done a lot of what I did in the Orchestrator in this. The nice thing about this is the logic apps, it's kind of got a visual type thing. If you like to code like me, that's why I chose the Orchestrator. But There's a lot of cool things that this can do. So you can see the events for this particular logic app that happened. You can see I had some failures yesterday. Now let's just look at what this logic app looks like. I'm going to go big screen for this so we can see this. All right. So the first step is I want to respond to some sort of event, right? So I'm matching up my Visual Studio. This is my Azure subscription. And I'm saying, okay, I want to respond to EventGrid topics. I mean, I could respond to a lot of different things, but this is what I'm looking for. And this is the Azure resource that I'm responding to, the Fix a Leak EventGrid. And then what I do is I have some let's close that. I initialize a few variables. So I want to get the job, I want to initialize a job code, customer name, and location. Those are things you saw in that email, right? Then I have some conditional logic. So you can do ands, ors, ifs, all kinds of stuff, right? First thing I want is I only care about this particular event, the Plumbers notified event, right? So if that's true, we're going to go into this flow over here. If you wanted to do something different, you could. I don't care about other events in this particular case. So the first step I do is I parse the JSON, right? So this is a built-in property that comes in on the event. It's called the data object. And when I published that event, you might have noticed when I made that call, I was passing the job item, that JSON structure, right? And what's really cool when you do the parse JSON, you can give it an example piece of your JSON, and it automatically create this schema for you so it knows what the properties are going to be. And then what I do is I get the job code off of the JSON object. I get the customer's first and last name and assign it to this variable called customer name. And I get the lat and longitude and assign it to a property or variable called location. Then I'm looping through, remember that object available plumbers? Let's see if I go get a job. Right here, available plumbers, has all the available plumbers. I'm looping through and sending an email, right? This is how I did a API connection with my Gmail account and made me do an OAuth connection. But let me show you this. There's so many freaking things that are built into this. So these are your basic built-in, out of the box logic app things, right? So I can call other logic apps, other Azure functions. I can do some inline code if I need to manipulate stuff. Got control logic, that's where you're doing the for each and conditional type stuff. I can make this thing come alive on a specific date and time, stuff like that. I can make other HTTP requests. Then you've got some basics, some standard stuff. This is where all these Microsoft partners have created integrations into this. Come on, finish loading. There's tons of these things. All right, so you see all these third-party, Act, tons of stuff, right? All these different things that integrate Basecamp, Bing Maps, Campfire. Just depends on what it is that you're trying to create, right? But you've got all these integrations, DocuSign, just tons of stuff, right? And this is where I was messing with the SMS connectors, which I obviously didn't set up correctly. My Twitter, whatever you want, right? Tons of integrations. Let's say if I wanted to do something with Stripe, right? Then it gives me the available actions, right? I can, obviously I wouldn't want to make a payment this way, but that's pretty cool. And then that's where I was messing around over here with this preview provider, sending a text. Didn't work, but that's kind of logic apps. And you can make them as simple or as complex as you wanted. And they're much like the Orchestrator that I showed you, but just in a visual, and behind the scenes, if you peek at the code, right? Let me show you. It's just creating JSON. It's just this big JSON file is what this whole thing is. And Microsoft Azure understands that. And so you can chain all these different steps and make something powerful. And it comes to life just like the orchestrator, the durable function, right? It comes to life and goes to sleep as needed. And so that's the part that handles the notifications, if we look back at the overall architecture, the notification service. That is basically a very, very, very simple microservice architecture. But I don't know if you picked up on it. There's a lot of pieces and moving parts. The great thing about microservices, they're part of the Cloud Native initiative. If you're building microservices using serverless technologies, or you're using something like containers, those things fit perfectly in any cloud, and they scale to whatever you need, right? But unless you're Netflix or Microsoft or Google, and you're building something that needs that type of architecture, like Martin Fowler, I would say you might want to think about it before you jump down that path, because there's a lot. Like I just showed you the code. We didn't even go into the continuous integration, deployment, automated testing that's required. Because if something is independently deployable and completely autonomous, you want to make sure as heck is what you're about to push out there is not going to affect all the other microservices in your application, especially if it's something that's very dependent in the whole process, right? So microservices are awesome. Use them with caution. Serverless, if you're doing anything in the cloud, serverless technologies like Azure Functions, in AWS, they have their Lambda functions. All the cloud providers got them. Is really simple, super cost effective. You could build your whole API, right? A REST API using serverless and put it behind an API gateway and only expose the things that you really need. So any questions about microservices, serverless, Azure Functions, any of the other things that I lightly touched on tonight?
So I have one question right off the top is, in our case, for our company, for instance, we have some limitations with trying to put some things in the cloud, but having limitations with our network and a lot of things being behind a firewall internal to our network that's not publicly accessible. In this case, in the cloud, what you're kind of showing is everything was inside the cloud in that case. So using orchestrators in this case, if it has to call some of those APIs that would be internal or whatnot, would it be practical to even pursue an option like this if you were having to spread that across multiple networks, or would it be more optimal
I
just to only pursue
think
this?
it takes a lot of thought in the architectural design and what you're trying to do, especially when you have something that's in a hybrid cloud where you have something that's on-premise and something that's in the cloud. You want to think about that communication. You can't, unless you're spending tons and tons of money, you can't really guarantee that connectivity is going to always 100% be up. So you need to code and design things in the event that connectivity is not going to be there. So one of the cool things that Microsoft Azure has is called their service relay bus. So if you have things that have intermittent connectivity but they need to interact with things in the cloud, you can use that. And it's a very secure, encrypted messaging and queuing solution where you can send messages back and forth between these things. If for whatever reason that connection's down, the service relay bus is going to persist that until that thing comes alive and then send the notifications. Good question though. But it requires a lot of thought when you're designing. You can't just assume that things are always up. Yeah, Jose.
What do you prefer, Azure over Amazon? Do you know the difference?
I can tell you that they're pretty much the same as far as features. From my professional experience, I've been using Microsoft's stacks and technologies, and so I'm just very familiar with Azure. But from what I've looked at in Google and AWS, they all have competing, they call them different things, but they have the same basic cloud native features. So Google may call it one thing, Amazon another, Microsoft a different thing, but those features are all there. Any other questions?
Do you think the microservice can adapt for the large scale application?
For a large scale?
Uh-huh.
It's meant for large scale applications. So if you have like 5, 10 different teams all building pieces of a larger application, that may be, and you may not be a Netflix where you're having, thousands of nodes on a network to support high demand, but you have a very complex application and you have a lot of teams that are building different pieces of it. That may be a perfect use for that style, that architectural style. But you got to think about it, right? All the overhead that's going to come along with it. Good question. Jose, you got another question?
Yeah. When you talk about overhead, what do you mean?
So overhead, like you saw that I had to break apart this application. I could have put it all in one .NET assembly, right? One web application that was handling all of that. But I broke it into 3, 4 different microservices and making HTTP calls to those. So there's an overhead in that so I've got these different projects that I'm having to deploy 4 different things. And in the real world, I would have a CI/CD pipeline that's doing continuous integration, continuous deployments on those things. I'd have automated tests in that pipeline for each of those microservices. And so there's overhead cost with that. And I'm using different technologies like Azure storage queues, things like that for communication, right? So if they were all in the same app, I could just be making function calls rather than out of band, out of network calls, right? So there's overhead.
So for excuse me, for a less basic architecture, maybe more scale, would you load balance the API gateway, or is that something that in practice is such low usage of resources that you don't have to?
Both in AWS and Google and Microsoft Azure, they have their own API gateways, and those things already have the dynamic scalability and elasticity that you'll need for that front end gateway. So you don't really have to worry about that. It'll handle that for you. Just like the functions or the Lambda functions, the serverless functions, it's got all that baked in. Now, if you're building a more basic architecture, like just a, let's say, web API or just a .NET web app, MVC maybe. So those, they already have features in there like Azure Service App in Azure, where you can just deploy your web app there, and it'll scale up, I think, to 30 or 50 nodes automatically. So and it'll scale back and down based on the traffic, and also based on what you say it can go to, because there's obviously a cost to that, right? And you can also define to what size node that you're using, right? What size server that's powering that, right? You need something with 4, 8 processors, how much memory, it just depends, right? But you have a lot of flexibility in that's what they call, what's the word? Not cloud native, but cloud ready. If you're building something and just deploying it to what they call the PaaS, platform as a service, deploying out there, you're going to get a lot of scalability and elasticity and resiliency already. Microservices is when you're talking hundreds or even thousands of nodes that need to be running, right? Maybe if I was writing an app that's going to power the election, that might be an excellent candidate for microservice. But you just have to look at the complexity of it. The app may be super complex, but doesn't require lots and lots of traffic. That might, like the gentleman right here was saying, you just have to kind of weigh what those costs are, and because managing lots of teams and lots of people, that's complicated, right? So it may make sense to do microservice architecture. Great question.
So as you scale up your entire application with multiple microservices, I feel like you'll also need to be making more calls to serverless functions. And I feel like does that add significant overhead in terms of like response time?
Oh yeah, anything distributed is going to have a cost to it. But the great thing about the serverless technologies is those things will spin up within 100 milliseconds. It's not as fast as if it was all running together, but so you got about 100 millisecond cost right there for that thing to spin up and respond. And spanning that over, so you got 100 microservices. Hopefully they're not all calling each other, but you know, when you chain them together, there could be things. So that's a great question, because when you're building and architecting your solution, you have to recognize when I submit this thing, I may not need a synchronous response back, right? You're designing for eventual consistency, and you gotta, you know, design for that. So it's a completely different user experience too, than when you're doing just a plain old vanilla monolithic app.
Cool, thanks.
Great questions. What else you got? Garrett?
Just kind of one of the more interesting problems I've encountered that I've heard that this can address was if you have a collection of different customers and you need to assign different customers to different versions of your app or different versions of different services. I heard that would that be part of this, or is that another one of the technology stacks in serverless that I was learning about?
So you're getting into versioning of APIs. You can do some of that in the gateway. The great thing about serverless is that, or just microservice architecture, you can have multiple versions of the same microservice running simultaneously. But you would want to kind of handle that, what's calling what, in a layer up above that. Usually